Okay, finding the area of this. So the area is when you integrate between 0 and 3. I'm just going to split this integral up. So putting the 4 outside, and then it's the integral of, I'm going to put that 5th outside, just to make it a little easier to see. Derivative is on top, so just log the bottom. EX, derivative is a 1, it's in front, so it just goes back to EX. Put in your 3 and your 0. So sub in your 3 now, so you get log 4 plus a 5th E3 minus 4 log 1, which is 0, plus a 5th E0, which is 1. So I have 4 log 4 plus a 5th E3 minus a 5th. Okay, going to the C4 paper from the same year. Question 1 is writing it in partial fractions. So it's A over the first factor plus B over the second factor. Sort out the tops. This first one needs an extra x minus 1 and the next one needs an extra x plus 1. Choose x to be 1. First bracket disappears, you get 2b. So b is a half. Choose x to be minus 1. So 1 equals a is minus 1 take away 1 is minus 2. So a is minus a half. It's a little bit squashed in there. So basically your expression can be written as a plus b is copying that down there. So there's your answer. When you're integrating that, I'm just going to write it out in this form. So you've got to split this. So minus a half 1 over x add 1 dx plus 1 over 2 1 over x add 1. The derivative, sorry, one of these should be a minus. The derivative of the bottom is on the top in each case. So just log the bottom. And we have no values to put in, so just write plus c. You could tidy that up if you want. So it's a half log this one, take away this one. So x minus 1 over x add 1 plus c. But the question doesn't ask you to tidy up, so you could just leave it in that line. Multiplications with integration by parts. Remember, u is the easier one unless it's a log. So differentiating that, you get 1. Integrating cos. What gives you cos? Sine gives you cos, so it's just going to go back to sine. Then writing out the formula, I always just write out the right hand side of it. So it's u times v minus v du by dx is just a 1. Now, where does sine come from? A cos goes to a minus sine. So I've got to put a minus in there and balance outside. So it's plus cos x add c. Now, another couple to do from this paper. Number 5, show that tan sec squared can be written like this. Now, what I'm going to do is I'm going to start off with the left hand side, having a wee think there. So it's tan x. I could write that as sec squared x times sec squared x. If you remember the formula, 1 plus tan squared x equals sec squared x. So I'm going to write one of those sec squared x's using this formula. So it's 1 plus tan squared. Have a look at what I'm heading towards. Multiply out your bracket. Tan x sec squared x plus, timesing that out, I get tan 3x sec squared x. Part 2, I've got to integrate this. So just take your previous answer and pop it in. I'm just going to split it up. So tan x sec squared x dx plus the integral of tan 3x sec squared x. Now as I'm writing that out, I'm thinking the derivative of tan is sec squared. So derivative, and I'm treating this as a bracket because I could integrate that. So the derivative of the bracket, if the bracket is tan, the derivative of that is sec squared. So treating it as a bracket, you add 1 to the power. So it's tan squared x, and you divide by it. Oh, I just checked and I want you to use a substitution. I'll finish off this way here. add 1 to the power, divide by it, and plug in your values. But they are specifically asking you to use substitution, which is a bit of a pain. But anyway, we'll just go through it. du by dx. Differentiating tan, it goes to sec squared. So du is sec squared x dx. So du over sec squared x equals dx. I suppose I should take that line out. That was me just automatically doing it as a bracket. So let's have a look. So it's tan x sec squared x dx is du over sec squared x plus tan cubed x sec squared x, and dx is du over sec squared x. Those sec squares cancel off. Tan is u du plus those cancel off, and tan is u. So it's u cubed du. So you add 1 to the power and divide by it. Add 1 to the power and divide by it. You've got limits in this case. When x is naught, u is tan 0, which is also naught. So that's my lower limit. When x is pi over 4, u is tan pi over 4. So in your calculators, or if you can remember it, so tan pi over 4 is 1. So subbing in your 1 over 2, add 1 over 4, take away 0 minus 0, add 0. So your answer is 3/4. Okay. Number 7 now we've got to do. A bit of space there. In number 7 we're looking for the volume. So if you remember the formula, it's pi, we're going between 0 and 9, and it's y squared. So it's e x over 3 dx. Never you square that out, because 2x over 6 gives you your x over 3. So derivative must be in front, balance outside. Derivative in front just disappears when you integrate it back. You've got wee values to put in there, 9 and 0. So it's 3 pi e to the 9 over 3 is 3. 3 pi e to the 0 is 1. So you could leave it like that, or you could tidy it up as e3 minus 1.